In today's lecture, we will learn some exact forms of differential equations and then we will take some special forms. Now, when it comes to exact forms, there is another phrase called as exact differential equations, but exact differential equations are not in your syllabus, only exact forms are in your syllabus. So, we can call them as exact forms or exact differentials. So, this means you can convert a certain term into an exact derivative. Okay. So, we will see some examples of these. Okay. So, basically these exact forms or exact differentials are also easily convertible to variable separable forms, where number of variables are not actually in terms of the variables, but in terms of the functions. For example, if you look at the first term here, so there is derivative of the function f2 and there is another function which is containing f2. Similarly, here there is an exact differential of f4, function f4, and there is another function containing f4. So, this way if we can get terms, we can convert them into variable separable, where a certain variable here, variable is treated as f2 here. So, f2 variable is separated, f4 variable is separated, f5 variable is separated, that way we can separate the variables and solve them. These are actually called as the exact forms. Now, to understand what exactly are these exact forms, we need to actually look into some exact forms, then you may understand what exactly are these exact forms. Okay. So, for example, these are some exact forms. So, if we look at the first one, it is basically d of xy. D of xy means x into dy plus y into dx. So, in certain questions, there may be a form like this. Then whenever you see this form, you can understand that it can be combined into one single exact form, which is the d of xy. So, d of xy is the exact differential here. Okay. So, like this you can also see what are the other forms. Okay. So, for example, this one d of y by x. So, how do we do this? We can apply the quotient rule or the division rule and write d of y by x. Okay. So, x into dy minus y into dx by x square, this can be treated as d of y by x. Similarly, we can also make d of x by y. Okay. So, just like this. Similarly, we can make d of ln xy. So, if you differentiate ln xy, so if you want to confirm, you can also differentiate and check. So, if you differentiate ln of xy, what do we generally get? We should be getting 1 by xy into d of xy. Now, d of xy is same as x dy plus y dx. So, that is how we have generated this form. Okay. So, like this, it is essential that you derive certain standard forms and learn how to derive them. Okay. So, after you go through this process, you can solve for the questions which are having these exact forms. Okay. So, let us look at some of the other exact forms. For example, if you have x plus y in the denominator and dx plus dy in the numerator, this dx plus dy can actually be written as d of x plus y. So, basically this comes under log of x plus y. Similarly, what about ln of y by x? So, ln y by x can be written as ln y minus ln x. Now, if we differentiate this, what do we get? The first term will give us 1 by y into dy, second term will give us 1 by x into dx, and we can further convert this into x dy minus y dx divided by x into y, right. So, in this, if there is plus sign here, it is d of xy, if there is minus sign, it is d of y by x or x by y. Okay. So, this way we can understand the forms, and also this tan inverse, this must be y here. So, tan inverse y by x also could be written in similar form like this. Okay. So, you can differentiate the RHS and derive the LHS. Similarly, the forms like this. Okay. So, you can just have a look at all of them and try to remember all of them. But out of all these 13, which are the most important ones? The ones that I am putting 2 ticks are the most important forms. 2 ticks means message sent and read by students also. Okay. So, this is important form. If you understand this, you also understood this. And this is one important form, this is another important form. Also here, this is one important form and this is one important form. Okay. So, this way you can understand that these are the exact derivatives. So, for example, let us say you get a form like this. You get a form like x square y square in the denominator, and here you get x dy plus y dx. Let us say a form like this. Then you must understand that this is nothing but d of xy by xy whole square, right. So, here our function f is basically xy, and here it is df into 1 by f square. So, this 1 by f square is the function of the function. Okay. So, this way if forms come, we know how to differentiate them, we know how to convert them into exact forms. That is exactly what we have discussed here. Okay. So, this function need not be only in terms of x, it could be in terms of x and y together also. So, here it could also be of this form, d of f of x comma y into another function of this f of x comma y. So, then also we can directly integrate them by converting them into exact forms. Okay. So, this is the idea. So, till now we have discussed only the idea. So, we will not get any grip of the idea unless we solve some questions. So, let us solve some questions and see how we perform there. Okay. So, till then you can make a note of this or you can take snapshot. This page also. And also this page. Okay. So, now let us look at some problems. Okay. So, there is one problem here. So, in general, whenever we solve any questions of this kind, what we try to do is, we first try to separate the variables. Now, with dx, if there are only terms involving x, we can integrate them. With dy, if we have terms only involving y, we can integrate them. But with dx, if there is y, with dy, if there is x, then there is a confusion. So, whenever we solve any problem, we first try to separate the terms which are easily integrable. Okay. For example, let us say we take this question. So, here we have x dx term, this does not have any problem. Y dy term, this also does not have any problem. And here x square plus y square is actually coming with dy. So, with dy, if x comes, then there is a trouble, right. So, we observe that this is the term which is actually creating the problem. Okay. So, this is the term that we have to deal with. Now, try to recall any exact forms that we have studied earlier related to the idea here. So, if you look at the first term, x dx looks like a familiar term, because when we differentiate x square, what is the differential of x square? We are not actually getting the derivative, we are just taking the differential. It is 2x into dx. What is the differential of y square? It is 2y into dy. Now, if I add these two, so that means d of x square plus y square, this will come out to be 2 common x dx plus y dy, right. So, basically we are getting an idea that because differential of x square plus y square is somewhat like this, if I can divide the entire equation with this term which is actually creating the problem, then we can solve the question. Okay. So, what we do here is we divide the entire equation with x square plus y square. So, what do we get here? X dx plus y dy divided by x square plus y square. This is one term, and the other term is now simplified into a simple form. Okay. Now, look at this. Is this in exact form? Now, it is in exact form. here variables y are already separated, but here our variable is going to be x square plus y square. Okay. So that means if I just supply 1 2 here and balance it, then we can integrate this easily. So that means let us put integral sign here and try to simplify. So what do we get here? It is half into integral of d of x square plus y square by x square plus y square plus 4 into integral of y cube into dy is equal to 0. So you know how to integrate this, because this looks like dt by t. What is the integral of this? It is the log. So we will get half ln of x square plus y square plus 4 into what is the integral of y cube? Y raised to 4 by 4 equal to some integrating constant c. So we can cancel 4 here. We can also take this 1 by 2 into the logarithm, then it becomes the square root, but it does not matter, you can also leave it like this. Okay. So here if you try to recall our earlier forms, there was one standard form here which was here. If you look at this, x dx plus y dy by x square plus y square, this must be equal to d of ln of root of x square plus y square. Even if you do not remember this, you can also solve the question just like the way I solved it. So if you do not remember all the exact forms, there is nothing to worry. You can just look at the problem, you try to manipulate the terms, try to do some rough work, do some experiments, explore, unlearn, and then solve the question. Okay. So this way if you practice more questions, you can get ideas faster. For example, as a teacher, because I have practiced many questions, so when I look at this, I directly get the idea that I will have to divide with x square plus y square. But for beginners, if you are beginning to learn these ideas, then definitely you will not get idea, but then you have to go for hit and trial approach. Okay. Come on, make a note of this. Let us look at another problem. So there is another problem here. What is the idea? Separate the terms which can be integrated easily and look at the other terms which have complications. For example, here if I multiply and check, we are getting one term as y dx. Of course, this has trouble because with dx we should have only variables of x, but here it is not the case. And from here I am taking one more term which is x into dy, and what are the other terms? X into y square into dx minus x square into y into dy is equal to 0. Okay. So here if you notice, there is not a single term which is already separated into separate variables. There is not a single term. But here if you notice, y into dx, x into dy, we cannot separate them. But here if we notice, there is xy square, there is x square y. But if you recall our exact forms, this x dy plus y dx, this can still be written as d of xy, correct? And here we have x into y square dx and here x square into y dy. Now look at this, is there any idea that is actually coming to your mind? Here it is already in one exact form, but here there is a trouble. So what I will try to do is, I will try to convert these terms into only terms of one single variable. So here the problem is with y square. So if I divide with y square here, I will get only terms of x, but here I have to divide with x square to get only terms of y. So what I will do is, I will divide with x square into y square. For example, here I am going to divide with x square into y square, here also x square into y square. Then what do we get? D of xy by x into y whole square plus, here when y square gets cancelled, we will get dx by x, and here when x square gets cancelled and y also gets cancelled, we will get minus dy by y equal to 0. So this experiment has resulted in positive values, okay, that means positive response. So every time we don't get idea, we have to experiment, we have to explore, we have to learn, okay. So now it is easy to integrate, okay. So I'll just put integral sign here. What is the integral of d of xy by xy square? It's going to be xy whole raised to minus 2 plus 1 by minus 2 plus 1, and here it is log of x, and here it is minus log of y is equal to constant c. Now I'll try to simplify this. So what do I get here? Minus 1 by xy plus log of x by y is equal to constant c. This way we can leave the solution, okay. So here if you observe, what is the idea that we have learned here? Always the equations are not separated into separate forms. We may have to do some experiments, okay. So if you have derived the earlier exact forms on your own, and if you keep them, you don't have to look at those list of exact forms every time when you are solving questions, because you have derived them on your own. While solving the question, ideas comes faster to your mind, okay. So just like the way we have solved it here, you can keep exploring and you can keep solving, okay. Come on, make a note of this also, okay. Can we move on to the next question now? Okay, so next question. Here we have one term which is x dy, I'll just leave it as it is, and here when I multiply and separate terms, what do we get? We get 1 into dx, so it is plus dx, this does not have any issues, and we have minus y into dx, this has issues, minus x square into dx, this does not have any issue. So what are the terms which are simple terms? These two are the simple terms. Now what are the terms which are having an issue? This first term and the third term. Now put them together and think about one exact form, okay. So here I'll get x into dy minus y into dx, and here I have plus dx, and here I have minus x square into dx equal to 0. Now think about one exact form here. If there is plus here, then that means d of xy, but there is minus sign here, so that means there must be one division rule or quotient rule. So you can think of two ideas, d of x by y or d of y by x. Now which is beneficial? Let us explore both of them, okay. Suppose let us say if I take d of x by y, so what do I get? I get y into dx minus x into dy by y square, correct. So to get this form here, I have to divide with y square. Now if I divide with y square, this first term becomes a simple term, but second term and the third term, these again cause complications. So dividing with y square is a bad idea. Let's go for the another idea that we got earlier, which is d of y by x. This will become x into dy minus y into dx by x square. So that means here if we divide with x square, is there any problem? Just check. When we divide with x square, this first term is simplified, second also does not have problem because it has only x, third also does not have problem because it also has only x. So that means now we can directly write the first term as d of y by x, and second term is basically dx by x square with plus sign, and here it is minus dx equal to 0. So here the idea was to divide with x square. See, if you have experience, you can straight away say that sir, directly divide this with x square, it will get converted. That is fine, but you need to get the idea. To get the idea, your mind has to process some ideas. So this is how you have to develop your experience, okay. So now we can integrate this directly. So what do we get here? Y by x, and here it is minus 1 by x, and here it is minus x equal to some constant c, okay. So this way we can solve the problem, okay. Come on, make a note of this also. Okay, can we move on? Okay, so next problem. So here there is one big differential equation, it is involving lot of trigonometric ratios. So what is our idea? first separate the terms which can be directly integrated. So before that, let me first simplify the terms. Okay. So here I am getting y into dx by cos square xy plus sin x into cos square xy into dx divided by cos square xy. Luckily cos square xy got cancelled, and the next term x into dy by cos square xy, and here we have sin y into dy. Now look at these terms. Are there any terms which are already separated into variables? This term does not have any issue. This also does not have any issue. Now the problem is with these two terms. So let us combine both of them. But in fact the denominator here, cos of xy, that is actually giving us a hint. And also if you check the numerator, it is having y dx and x dy. Okay. So we can write this as y dx plus x dy by cos square of xy. And this is nothing but d of xy by cos square of xy, right. So this term is actually converted into one single exact differential. Okay. So I will just separate this. What is the next term? Next term is this sin x into dx, and this term is sin y into dy equal to 0. So we can write the first term as sec square of xy into d of xy, right, and this becomes sin x into dx, and this becomes sin y into dy, okay, equal to 0. Now let us integrate this. So what is the integral of sec square theta d theta? It is tan theta. So we can write tan of xy here, and here integral of sin x is going to be minus cos x and this is going to be minus cos y and equal to some constant. Okay. So this way we can solve this problem. So every time we don't get exactly simple forms, sometimes we may have to generate them. So this is how we generate, because till now we have not learned this idea, especially this tan of xy, the d of tan of xy we have not learned it, but we generated it. So this way if we think, there are infinite exact differentials. Depending on the situations we have to generate them, we have to use them. Okay. Come on, make a note of this. Okay. Now let us solve another problem. Okay. Now this is a little different problem, but we can also still solve this. What is the first step of solving? Try to separate the terms which are easily integrable. Now there is equality here, we can also take the term to LHS and simplify. Okay. So let us write all the terms here. We are having 2x square y square into dx plus y into e raised to x into dx, okay, and minus e raised to x into dy minus y cube into dy equal to 0. So out of these, which are the terms which are easily integrable? This is the term which can be easily integrated, but other terms are not. Other terms cannot be integrated directly. But these two terms are actually giving us a hint, because here in this differential equation e power x is involved, and there are only two terms here which are having e power x. So there must be some idea involving these two. And if you look at the sign here, it is minus sign. Now we get minus sign between two differentials only when we take the quotient rule, that is f of x by g of x. When we differentiate this, we will get minus sign. So that means you can write it this way, that it is y into d of e raised to x minus e raised to x into d of y, right. So it looks like the quotient rule. If there is y square here, then this will get converted into one exact differential. So this is our idea. Now we got the idea and we have to explore if this idea is correct or not. So we get, first we get the idea, then we have to check for the confirmation test. How do we do the confirmation test? Divide the other terms with y square and see if they are able to get converted into simple form or not. If I divide the last term with y square, we still don't have any issues because it's only in terms of y. And if we divide this first term with y square, then the trouble got cancelled, right? So it is working. So this idea is working. Now we can write it like this. The first term becomes 2x square dx. The second term becomes d of e raised to x by y, and this term becomes y into dy is equal to 0. Okay. Now further we can integrate this directly. Integral. So what will be the expression here? 2x cube by 3 plus e raised to x by y minus y square by 2 is equal to some constant c. Okay. So this way we can solve the problem. So every time whenever we solve any question involving these kind of forms, what is the idea that I have been saying? Idea is, first mark the terms which are easily integrable, separate them and take the terms which cannot be integrated directly and try to manipulate or supply some terms, divide some terms, multiply some terms and try to recall your exact forms and try to fit in there. Okay. So this way we can solve all questions of exact forms. Okay. So with this we close the exact forms. Now we will move on to the next idea, but before that make a note of this. Okay. Now let us move on to the next concept. It is called as the differential equations of first order but higher degree. For example, I am taking the second degree first. It can be higher degree. So in general, when it comes to the JEE syllabus, whether it is IIT or mains, only differential equations of first order are in your syllabus and also of the first degree. But if there are any questions involving second degree but still first order, second order is also not in your syllabus. So first order, second degree, if you get any situation like that, then what is the idea? Then the idea is to convert them into first degree and solve the question. Now how do we convert them into first degree? By solving or something. For example, let us say I take one equation, differential equation of first order but second degree. It may have one y dash square and it may have some function into y dash and it may have another function into y or something, it does not matter, this must be 0. And here this function need not contain only one variable, it can also contain two variables, f of x comma y, here also g of x comma y. Okay. So if at all we get any equation of this form, what do we have to do? We have to convert them into the equations of first degree. How do we do that? We solve for y dash. Just like treating this as quadratic equation, we solve for y dash and whatever we get for y dash we integrate it and we try to solve it. Okay. This is the idea. So the idea is to convert them into first degree and solve. This is the first idea that you will explore. If this does not work out, then there are two more methods. Okay. So here are the methods. Method 1 is to write the differential equation as y equal to f of x comma p, where p is the derivative y dash. Okay. So basically keeping only y in LHS, we take all other terms in the RHS, but RHS should not contain y, it should contain only x and y dash. After writing this form, we can differentiate this entire equation with respect to x and then proceed further to solve it. Now further, what is going to be the method that we will apply to solve it, that will depend and it may vary according to the question, but you can solve it on your own at later stages, because all the other tools that are required you have already learned them. Now there is also another method. Here the idea is to write x in terms of y and p. Okay. So keep only x in LHS and write as a function of y and p means y dash. Now here we have to differentiate with respect to y to arrive at the next step, and then again proceeding further involves other ideas that we have learned already. Okay. So here there is one simple idea. If you are keeping y in LHS, you will be differentiating with respect to x. If you are leaving x in LHS, you will be differentiating with respect to y. It should be the opposite. Okay. So these are two ideas. So whenever we get any equation of this kind, our algorithm goes like this. First we hit the first idea, then we go for the next two methods. Okay. Let us see some examples of this kind. For example, let us say there is a question here. So these questions are actually the illustrations. So from now onwards, whatever are the questions that I am doing are basically some illustrations. Now look at this. It is of course quadratic in terms of y dash. Okay. So we have y dash square here, here we have y dash, and there are two functions here. So our goal is to get linear, that means y dash equal to some expression. So how do we do it? We can apply the formula of quadratic, or if it can be factorized easily, we can go for the factors. Okay. So what are the factors here? This is easily factorizable. We will explore the other ideas in the next questions. Okay. So here if we observe, this can be written as x into x plus y, and this 2x plus y can be written as x plus y. So it is easily factorizable. So we will get the factors as y dash minus x into y dash minus x plus y is equal to 0. These are the factors. Now separate the two factors and solve them separately. So if you take the first factor, which is y dash equal to x, y dash minus x equal to 0 or y dash equal to x, what are the solutions we will get here? Y will be x plus x square by 2 plus some constant. Okay, right? So basically we will get one curve here. Okay, and it is actually family of curves. Okay, so we will get a family of curves here. If you look at this curve, it is going to be parabola. So we will get family of parabolas. Now let us look at the other case. It is y dash minus x minus y equal to 0. Okay. So how do we solve an equation of this kind? There are two ideas. We can put x plus y equal to z and try to solve it, or we can apply the idea of linear differential equations and solve it. So that means, let us say I am applying the linear differential equations here. So y dash minus y is equal to x. This becomes our differential equation. What is the integrating factor? It is going to be e raised to minus 1 into dx, which is same as e raised to minus x. Now how do we solve it? Integrating factor into dependent variable is equal to integral of integrating factor into RHS dx. Okay. Now further, how do we solve this? You know how to solve this. This is by integration by parts. So e raised to minus x by minus 1 into x minus integral of e raised to minus x by minus 1 into derivative of x is 1 dx. So what will this give us? Minus e raised to minus x into x, and here it becomes plus, and here it is e raised to minus x by minus 1 plus some constant c, and this is basically e raised to minus x into y. So y is coming out to be minus x minus 1 plus c into e raised to x. Okay. So we can write the next solution as y equal to minus x minus 1 plus c into e raised to x. Okay. So, this way we can solve the question. So, here if you understand what is the overall method, what is the overall process to convert the given second degree equation into first degree equations. So, if it is second degree, we will get two first degree equations. If it is third degree and if it can be factorized into 3 factors, we will get 3 first degree equations and we can solve all 3 of them in the similar manner. Okay. So, this way we can solve the problem like this. Okay. Come on, make a note of this. Here also. Okay. Now, let us look at another example. So, here also it is one second degree equation. So, let us explore our first idea and see if it works or not, and then if not, then we will go for the other ideas. For example, here it looks like x into y dash square minus 2y into y dash minus x is equal to 0. Now, when I solve for y dash here using the ideas of quadratic, so what do we get? Minus b plus minus root of b square minus 4ac. So, it becomes plus 4x square divided by 2 into x, right. Now, luckily 2 gets cancelled here and we get y plus minus root of x square plus y square by x, this is y dash. Now, looking at this, are you getting any idea here? When we solved for y dash, we got an expression in RHS, but if you look at RHS, RHS is already in homogeneous differential equation form. So, because RHS is homogeneous expression, we can apply the ideas of the homogeneous expression here. So, luckily we got one homogeneous here. If this was not homogeneous, then anyways we observe that it is not convertible to variable separable, and if it is not homogeneous, then of course we cannot solve this using the existing conventional methods. But here luckily it got converted into homogeneous form. Okay. So, the idea is going to be like this. Suppose let us say if you want to use the homogeneous form, we will be writing y dash as y by x plus root of 1 plus y by x whole square, this is one form. The other form is y dash equal to y by x minus root of 1 plus y by x whole square. So, here we will be writing y by x as our z and we will be solving this. Okay. So, that is one idea. You can explore this idea on your own and look at the solutions and try to compare the solutions with the solutions that I am getting using a different method. Okay. So, this is one idea which you can always apply. Okay. Now, let us apply those methods that we have discussed on the same question and see how it applies. Okay. So, this is idea number 2. So, we always take y dash as p, okay, and the equation is going to be x into p square minus 2yp minus x equal to 0. Okay. So, what is the idea here? Either write y in terms of x and p, or write write x in terms of y and p. Okay. So, here I will go for any one of those ideas, it does not matter which one you choose. Okay. Suppose let us say I keep 2yp on one side. So, we get 2yp equal to x into p square minus x. So, y becomes x into p square minus 1 by 2p, right. Okay. So, I can also write it like this, x by 2 into p minus 1 by p. Okay. Now, we got y as a function of x and p. Now, what is the next step? Differentiate this with respect to x both sides and see how it proceeds. So, we do not know what is going to happen at after the next step, but we have to wait and see. Okay. So suppose let us say I differentiate this. So what do I get if I differentiate? LHS will be y dash, which is same as P, and RHS will be, here we have to take these two as two different terms and differentiate using the product rule. So we will get something like x by 2 into P dash minus 1 by P square into P dash, okay. And next I am going to differentiate x by 2, which will give me 1 by 2 into leave P minus 1 by P as it is. So I have performed the derivative here. Now we have to simplify this, okay. So let us simplify this. I will get, let us say if I multiply with 2, I will get 2P is equal to x into P dash. If I take common, I will get 1 by 1 plus P square here, and here I will get P minus 1 by P, okay. So whatever are the terms which are having x, keep them on one side, and whatever are the terms which are not having x, keep them on the other side. So basically I am trying to hit for the variable separable idea, okay. So let us take this term P minus 1 by P to LHS. So what do we get here? 2P minus P plus 1 by P is equal to x into P dash into 1 plus 1 by P square. So it is going to give us P plus 1 by P in LHS, okay, P plus 1 by P, and in RHS x into P dash into 1 plus 1 by P square. Now if I cross multiply and check, so what do I get here? X into P dash and P square plus 1 by P square, okay. We got an equation like this. Of course we can cancel out terms here, but do not cancel blindly, okay. So let me just take this to the next page and solve it. So basically if you observe the process, we have written y as a function of x and P and then differentiated with respect to x, and then now we are exploring how to proceed, okay. So let me just write this in the next page. So we are getting P square plus 1 by P is equal to x into P dash into P square plus 1 by P square. Now there are some terms which may look like they get cancelled, but we should not cancel them blindly, because if we cancel blindly we are basically missing a solution, okay. So what are the cases that are actually getting cancelled? P square plus 1 can get cancelled, so equal to 0 is one possibility which we should not ignore. Next, P can get cancelled in the denominator, so P equal to 0 is one possibility we should not ignore, okay. But because P is coming in the denominator, P should not be equal to 0, okay. It should not be equal to 0 because it is coming in the denominator. Let us look at the other cases. So when we cancel these two, we will be left with 1 equal to x P dash by P, okay. This is the only factor that is left out. Now let me just explore this part once again using the equation. If you look at this equation, in this equation P equal to 0 is perfectly valid because P is not in the denominator, but because we wrote y as a function of x and P, P came in the denominator. We modified it, we arrived at this. So P not equal to is 0 is the problem that we have to handle on our own, because that arised P came in the denominator only because we simplified it. So we have to take P equal to 0 and explore it, okay. So here I have explained why we should be taking P equal to 0, why we should not be taking P equal to 0. Both cases I have explained here, okay. So now if I put P equal to 0 here, what do I get? P equal to 0, P equal to 0, it will give me x equal to 0 as the solution, okay. This is one part, okay. And now let us look at this equation. P square plus 1 equal to 0 will have complex roots, That means P will be equal to I or minus I. P is what? P is nothing but y dash. So derivative equal to complex values. Of course, this equation is imaginary equation. This does not have any real solutions. So this is leading to no solution. Okay. Now let us look at the other case here. Here we can write this as, so when I separate the variables, we can write first RHS as x into x by p into dp by dx. Now when I separate the variables, I will get dx by x equal to dp by p. So when I integrate this, what do I get? I get a term like this. What is the integral of this? Ln p is equal to ln x plus constant I am taking as ln c. Okay. This is ln c. So this becomes p equal to x into c. Okay. Now what is p? P is nothing but y dash. So y dash is basically coming out to be x into c. If we want, we can integrate this further, or we can directly take this relation, put it in the given equation and get one solution directly. Okay. For example, here if I put p equal to x into c, what do I get? X into c whole square minus 2y into x into c minus x equal to 0. Now, if you notice, x is coming out to be common. So, x equal to 0 if I take one case outside, and what is the left out case? X square into c square minus 2cy minus x equal to 0. Sorry, this must be 1. Okay. Here it must be 1. Okay. So basically we got one solution here where x equal to 0 was one possible case, which also of course we got here. Okay. So I hope you have understood both these ideas. Now coming to this, we can also write y as 2cy equal to xc square minus 1. So x square c square minus 1 by 2c. So it becomes x square into one constant, which is c by 2 minus 1 by 2c, this is another constant. So we got a solution like this. Suppose let us say you did not follow this idea and you straight away went for the integration once again, then also you should be getting similar solution. Okay. For example, let us say we integrate this, what do we get? Y equal to x square by 2 into c plus some constant d. Okay. So just check if it is matching or not. Of course it is matching till the coefficient also, but only this last constant is different. Okay. So this way basically we can solve the question. Okay. So here if you notice in this problem, applying the algorithm of the method is one aspect, but understanding each and every aspect of the solution is another aspect. That is exactly the meaning of the complete mathematics. Okay. So if you want to master mathematics, you should be careful with each and every step you are writing. Okay. So I hope you have liked this solution. Come on, make a note of this. Starting from here, this page also. This page also. Okay. Now let us move on to the next concept. This is also one second degree or probably higher degree equation, which is in this standard form. Okay. So instead of writing the second degree, we can also write of higher degree. Okay. It's called as Clairaut's equation. Okay. Clairaut's equation. The equation should be in this form always. So here the form looks like this: y equal to x into y dash plus some function of y dash. Okay. The form is going to look like this. This is called as the Clairaut's equation, and the method to solve this is same as the earlier method that we have learned. Okay. So, to understand this, let us take one illustration and try to solve this. So, let us take this illustration. So, here there is y dash square here, there is y dash here. Okay. So, if you want to solve the problem, we have to differentiate this with respect to x, that is the idea. So, suppose let us say I differentiate this with respect to x, what do I get? Y dash is equal to x into y double dash, but we are actually writing this as y dash as p. So, let me just take p and explore it, and then we will go for the y double dash and see what happens. Okay. So, when I differentiate, what do I get? Y dash is equal to x into p dash plus p into 1 plus 2p into p dash, and y dash is nothing but p only. So, luckily here p is getting cancelled. Now, after that, what are the terms that are remaining? X into p dash plus 2p into p dash is equal to 0. This is the term which is remaining. So, here we can take two cases. One is p dash equal to 0, this is one case. The other case is x plus 2p is equal to 0. This is the other case. Okay. So, now further p dash equal to 0 means you can try to solve this further, or you can go for the solution given by the next part. Okay. Suppose let us say if I solve this, what do we get? X plus 2 into dy by dx is equal to 0, which is nothing but x into dx plus 2 into dy equal to 0. So, which is going to give us x square by 2 plus 2 into y equal to constant, or we can also write this as x square plus 4y is equal to 2c, which is same as some other constant k. Okay. So, it is going to be family of parabolas, right. Now, let us look at this part. Okay. Suppose if p dash is 0, it means y double dash is 0, which means y dash is going to be one constant function. Let us take it as k1. That means y is going to be linear function k1x plus k2. So, here we got two factors, and when we solved two factors, we got two different solutions. Now, this is actually giving us lines, this is actually giving us parabolas. Now, what is the connection between these lines and parabolas? What is the connection? To understand the connection, of course, I can say the answer, but let me take you through the process so that you will get the idea before I say it. Okay. Now, let me take this equation. It is y equal to x into y dash plus y dash whole square, right. Now, what does y dash represent? It is the derivative. What is the meaning of derivative? Slope of the curve at a point. What is the slope of the curve? It is also slope of the tangent. Suppose if I put y dash equal to m, if I put y dash equal to m, what do I get here? I will get an equation like this, y equal to mx plus m square. Now, is this form a familiar form to you? Recall your coordinate geometry. This is basically tangent of one curve, which is the parabola, which is x square equal to 4ay. What is the equation of tangent to this? Y equal to mx minus am square. You recall this? Now, if you compare this with this, the value of a is coming out to be minus 1. So, the equation of the curve must be x square equal to minus 4y, which is also same as x square plus 4y equal to 0, right. Okay, so we got one curve here, we got one tangent here. Now, what is the connection? Connection is this. The lines that we got here are basically tangents of this curve. Okay. So basically if there is one family of differential equation which is representing a family of curves, then the tangents also will satisfy that differential equation. That is one beautiful result that you might have not explored till now. Okay. So if there is one differential equation and if you get a solution of that and the solution is a curve, then tangents of that curve will also satisfy that differential equation. That is the factor that we have explored here. Okay. So now coming to this, it may look like this. The parabola is going to be somewhat like this and the tangents are going to be this way. So the first equation is actually giving us family of tangents. The second equation, the curve, which is actually touching all tangents and moving. So this curve is also called as the envelope. Okay. So it is the curve which is touching all tangents and moving. So it is actually forming a boundary which we can also call it as envelope. Envelope means it is the boundary which is covering all of them. So basically this solution is also a solution, it is plus here, and this is also a solution, okay, and here this solution is called as the singular solution. In mathematics it is called as the singular solution. You do not have to remember these terms, you have to remember the idea of solving it and the geometric interpretation, that is it. Okay. So here we have understood how to handle this Clairaut's equation algebraically and what is the geometric interpretation of this kind of equations. We have understood that, and with this point we will close today's lecture. I hope you have liked the ideas and the techniques that we have discussed and also the explanation that I have given. Okay. So if you like the lectures, you can also make comments on app, you can also share the feedback, and also keep taking care of your health. Be healthy, eat healthy and be healthy. We will meet again in the next lecture with another new concept and a little mixture of the ideas. Until then, have a great learning day. Have a great learning day. Learning shall never stop.